Hello, and I hope you are doing well. Today we did a model of the damage and crack identification by using piezoelectric or PZT of a concrete beam. You can see this is a concrete part here, and we have two PZT blue and red at the left and right of the concrete, and we applied the load. The load can be electrical potential, displacement, force of pressure on the piezoelectric, and then the piezoelectric convert that. If you apply electrical potential, piezoelectric converted that to the displacement, and it means force or pressure on the concrete. And we have the wave here, and let me make it this free edge to have a better view in this view, and let me replace the concrete here. This is the concrete, and now click here. If I click on animate, you can see the stress pulse which is come from the uh, piezoelectric or PZT. You can see here, you can see this is the pulse. It is moved here. These are the something like wave, the stress wave or displacement, velocity wave, anything. You can see when it arrived here, it is disappeared because here we have damage. See the damage, and we can check, for instance, stress, for instance, F33, because in this direction we have this. And now let me make a limit. For instance, make it 1E4, and now click on animate. See here, these are the wave, and it is too much. Let me make it 12, 15. What is the maximum? 1E4. Make it 1E5. You can see, make it 70. It is better. Then click here again. Now let me make it auto compute. So make it discrete like this here, and now we can make it show edges here. See the edges. See here. So this is the graphical thing, this is a graphical thing, and we can also use it black and white, but the rainbow is better. But how can we find the crack location by using this PZT method? See, this is the PZT here, also the stress in the PZT. How can we find it? Just we need to define a path here. This is the path here. You can see this is a path, and these are the sensors, for instance. And then we can draw anything in the path. For instance, the stress, plot it. Okay, see the stress. The stress is this. See here. This is the diagram of stress. And also we can check another. Let me draw the another diagram for the stress. For instance, create another path, continue, add after. For instance, this is the first point in this line, this is the second, this is the third, for instance, and this is the here. This is the last one, for instance. And now pass, select pass 2, for instance, stress plotted. See, here it is better. Here we have the increase in the stress, but here we have a decrease. We have a decrease here, and what is this? Here happen. See here, if I move here, this is exactly 100 millimeter or 10 centimeter. And what is the peak here? The peak here is exactly 99 millimeter. So in the 99 millimeter to 100 millimeter, we have something weird, you know? We have something weird here. And what is this? 1 millimeter length in this location. Let me go back to assembly. Uh, where is it, the assembly? Here is the assembly, the part. And this is the assembly. Now let me find the distance. The distance of the front edge, this is the front till here. See, it is exactly 99 millimeter. And here to here, it is exactly 1 millimeter here. This is the length of the crack, sorry, and this is the distance of the side view or from the piezoelectric 99 millimeter. And what is this? By this effect of the piezoelectric, we can find the damage. Where is it and what is the length of the piezoelectric? We can also use piezoelectric on the side of the concrete here to find the elevation of the crack. You know, we can use that also. And then we can check the electrical potential. This is the negative because this is a vector, or its gradient, for instance, the potential gradient, displacement, or anything else. Let me again make this free. Let me request displacement or velocity, the velocity. And we can use also isosurface. See the velocity here. Let me make it discrete. See the discrete, it is the discrete, and this is the continuous. Let me check it for the isosurface. See the isosurface. Let me replace just the concrete, it is better. And now run this here. See, the crack and the damage has this effect. See this effect? Okay. So if you need this tutorial, you can come to our website abaqusfm.com. Find the English tutorial here. This is the English tutorial. Click on the title or blue sign. Then you will have the geometry, material, step interaction, load, and the result as figured here. And this is the diagram that I showed you. And you can provide CAINP English video file, step-by-step paper just for 30 euros. You can use a PayPal account, a Visa or MasterCard for the payment. Before payment, send me an email to this address. Thank you for your attention.